5-7, scatter plots and trend lines. So our objective is to write an equation of a trend line and the line of best fit to use a trend line and a line of best fit to make predictions. So our essential understanding is that you can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a line to estimate or predict the values. So a lot of what we're going to do in this section is looking at data, analyzing data, and an introduction to some stuff that you would see in a statistics class. So first we have a scatter plot. Okay, a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatter plots are in the first quadrant of the coordinate plane because the data are usually positive numbers. Makes sense, right? Most things that were going to happen in real life usually going to use positive numbers. Okay, you can use scatter plots to find trends in data. The scatter plots below show the three types of relationship that two sets of data might have. Okay? So we see here, we kind of have all the data going up. Okay? When this happens, when y tends to increase as x increases, the two sets of data have a positive correlation. We can see in this one, we can sort of make a line through the data and it is going down. When y tends to decrease as x increases, right, as the graph goes down, as x goes right, the two sets of data have negative correlation. And when x and y are not related, because the points are all over the place in this graph, the two sets of data have no correlation. Okay? So our first problem here is to make a scatter plot and describe its correlation. The table shows the altitude of an airplane and the temperature outside the plane. Okay, so let's take this data. Let's make a real basic plot. All right, let's go by the thousands here for my altitude. Okay, and then for my temperature, let's go by the 20s. 20, 4, ooh, whoops, 40, 60, and 80. Okay, so at 0, it's 59. At 500, it's a little bit warmer. At 1,000, it's 61.3, a little bit warmer too. But then, watch what happens when we get to 1,500, we have 55. 2,000, we have 41. 2,500, we got 29. That's like halfway. Right about there. 3,000, we got 29.9 again. Down to 18. 4,000 feet, we're back up to 26. Okay. 4,500 feet, we're down to 4,500 feet, we're down to 12. And at 5,000 feet, it is temperature is 0.6 degrees. Okay. So if you look at this data, yeah, not every point goes down, but the general form of this graph is that the temperature outside the plane tends to decrease as the altitude increases. So this has a negative correlation. Okay, let's look at another one. Okay? Make a scatter plot. Okay, so I'm going to do the same thing with this one. So let's get a little bit more room. So this is gasoline. So with this graph right here, I'm going to graph the amount of gas bought versus the dollars spent. Okay? So usually when you buy more gas, it costs more money. So we're going to expect this to have a positive correlation. So let's do this. So gallons bought, let's go 1, 2, 3. Okay, and then dollars spent, let's go by twos. 2, 4, 6, 8, 10, 12. Okay, this is dollars. This is gallons. Okay, so 10 gallons cost 2.50. 11 gallons cost $2.80. 9 gallons, 2.3. 13 gallons. Okay, that 13 gallons costs $3.30. 5 gallons, $1.30. 8 gallons, $2.20. And 4 gallons, a little over $1. Okay, so we see this has a positive correlation. All right, let's look at part B. Consider the world population of a city and the number of letters in the name of the city. Would you expect this to have a positive correlation, a negative correlation, or no correlation? Well, if you think about it, what does how many people live in a city have to do with the name of the city? New York is one of the biggest cities in the country. Has nothing to do with the fact that there's only 8 letters in the name. Okay? So no correlation. When two sets of data have a positive or negative correlation, you can use a trend line to show the correlation more clearly. A trend line is a line on the scatter plot drawn near the points that shows the correlation. And you can use a trend line to estimate a value between two known data values or to predict a value outside of the range of known values. Interpolation is estimating a value between two known values. Extrapolation is predicting a value outside of the range of known values. Right? So we can say, well, this point is probably going to be there. That's interpolation. And this point is probably going to be out there. That's extrapolation. So make a scatter plot of the data, and let's find the approximate weight of a 7-month-old panda, which is not one of the data points on there. So let's go 2, 4, 6, 8, 10, 12. Okay. And then let's go, this is months. And then let's go pounds. Let's go 10, 20, 30, 40. Now they go higher. So let's go 60. Okay. So 1-month-old panda, and we expect this to have a positive correlation, right? As the panda gets older, it's going to get heavier, right? We're going to feed it, going to get heavier. So 1-month-old is 2.5 pounds. 2-month-old is 7.6. 3-month is 12. 4-month is 17. 6 months is 24. 8 months is 37. Okay. 10 is 49. And 12 is 54. Okay. So we have our approximate graph. I can make a approximate trend line to go through it. So we can now, that's my scatter plot. Okay. So now let's, instead of just guessing where a 7-month-old is, because we think it would be about 30-ish. Okay? Let's make the equation of the line so we can actually calculate this. Okay, so to find the equation of the line, I'm going to need the y-intercept, which I don't have, or 2 points. Well, I have 2 points. There's a point, and you can use any point on here. Let's use that one right there. Okay, so there are 2 points on the line. So point slope form, if you remember, is y minus y1 is equal to m times x minus x1. Okay, when we have 2 points, now we just need the slope. So let's calculate the slope. So my slope is going to be y2 minus y1 over x2 minus x1. y2 minus y1 is going to be 17.1 minus 2.5 over 4 minus 1. Okay. This gives me 14.6 over 3. And that gives me an approximate slope of 4.86. Okay. Now, because this is an estimate of the data, okay, your slope is not going to be exact between all of these, right? Some of them, right, this says as you go up a month, your weight will go up 4.8 pounds, or about 5 pounds. Okay, so if we look at this, right, this is kind of, that's 5.1, that's 4.9, right? They're different amounts each time. So this is just going to be an approximation. Okay, so, but a little bit better than guessing. So now let's use any data point. Let's use the 4 and the 17.1. So y minus 17.1 is equal to 4.86 times x minus 4. Okay. So my formula becomes, let's distribute first, minus 17.1 is equal to 4.86x minus 19.47. Okay. Add 17.1 to both sides. And I get y is equal to 4.86x plus 17.1 gives me minus 2.37. Okay. Now, if I want to find there's my equation, right? Slope-intercept form. If I want to find a 7-month panda, I just plug in 7. So y would be equal to 4.86 times 7 minus 2.37. Calculating this, 4.86 gives me about 31.6. Okay, which is kind of how much our graph told us, right about there, right? A little bit above 30. Our graph, not super, super accurate, but good enough here. Okay, so point slope formula, pick 2 points, find the equation, plug in x. Remember that this is an approximation and it will change depending on the slope. Okay, so same idea here. We are going to make the equations and the scatter plot. I'm not going to make the scatter plot for this one. Let's just solve an equation. So we got to pick 2 points. How about that one? And I like this one, 5. Okay, so y minus y1 is going to be equal to m times x minus x1. Okay, plug in, oh, whoops, find the slope first. So the slope is y2 minus y1 over x2 minus x1. y2 is 20.1 minus 8 over 5 minus 1. So 20.1 divided, or sorry, minus 8 gives me 12.1 over 4, which gives me 3.025. Okay, so now that I have my slope, leave the point there. Let's use the point with the 5 in it. So y minus 20.1 is going to be equal to 3.025 times x minus 5. Okay, y minus 20.1 is 3.025x minus 15.125. When I distribute, right, multiply, multiply. Add 20.1 to both sides, and I get y is equal to 3.025x plus 4.975. Okay, x in this case is going to be equal to 7, and I know it's going to be somewhere in between here. Okay, so let's hope we did this right, which I'm pretty sure we did. So x is 7, so y is going to be equal to 3.025 times 7 plus 4.975. Plus 4.975, and it gives me 26.15. Kind of what we expected, right? Somewhere in between there. Good. Okay. Now this next section is going to talk about the line of best fit. Okay. In order to do this, we are going to need some sort of graphing calculator or something on the internet, which I'll show you. Okay, so the trend line that shows the relationships between two sets of data most accurately is called the line of best fit. A graphing calculator computes the equation of the line of best fit using a method called linear regression. The graphing calculator also gives you the correlation coefficient, R, which is a number from -1 to +1 that tells you how closely the equation models the data. The nearer R is to 1 or -1, the more closely the data cluster around the line of best fit. If R is nearer to 1, the data lie close to the line of best fit with a positive slope. If R is near -1, the data lie close to the line of best fit with a negative slope. So if the number your calculator spits out, this R, this correlation coefficient, if it's negative, your line's going to be going down and all the points are going to look almost like a line. As you start to go this way, the line is still going to be going down, but the points are going to be more scattered out, right? This would not have a correlation of 1, right, or -1. This would have a maybe a 0.6 or 0.5 or something like that. Okay. As you get here to 0, the points are going to be all over the place. Okay. So when you have your graph, right, your points are all there, so no correlation there. As we start getting closer and closer to 1, now that would have a very, very, very high correlation, close to 1. This, right, more data, more data, more data, would not. Yeah, I can still draw a line that approximates everything, but some of these things are far away from the line, and some are very close. So my correlation is going to be much lower, like 0.7 or ish. Okay, so we're going to use a graphing calculator to find the equation of the line of best fit for the data on the right. And what is the correlation coefficient? So we're going to need some sort of utility, some sort of graphing calculator. So we can just flip over to Google and Google linear regression calculator. Okay? And I was playing with this one a little bit, Acula, so I'll go on that again. So it says enter the x, y values, numbers only. So what I'm going to do is I'm going to enter these values right there, okay, where x is going to start, right? X is 2000, 2001, 2002, 2003, 4, 5, 6, right? We don't want to put a range in for x. And here are my y values. So I'm just going to type these in to my graphing calculator, and it says enter x comma y, numbers only. So I'm going to enter 2000 comma 3508, or sorry, yeah, 3508, 2001, 3766, 2002, 4098, 2003, 46, 45, 2004 was 5126, 2005 was 5492, and 2006 was 5836. No comma. 5836. Okay. So now, when I submit this data, I'm going to get a equation of this data, the linear regression. Unfortunately, this particular program, which I didn't check before, it does not give me the correlation coefficient, so I would have to try a different one to get that. But I can see from the graph it's going to be very, very close. Right? So the question then asks for the cost of attending in 2012. Well, now that I have the equation right here, this calculator also lets me type in other data points. And it's going to cost about $8,300 to go to this particular school 6 years late. Okay. Unfortunately, there's not a way to do this by hand. So you're going to need to find some sort of good graphing calculator that, number one, you like, and number two, spits out all the data. So I would actually need a different one if I wanted to find the correlation coefficient, like I said. Okay. Causation is when a change in one quantity causes a change in the second quantity. Correlation between quantities does not always imply causation. Okay. So, in the following situations, is there likely to be correlation? If so, does correlation reflect a causal relationship? Okay, does one thing cause the other? Okay, so we're going to see, are these things related? And if so, does one cause the other? The number of loaves of bread baked and the amount of flour used. Well, first of all, I would say that this would have a positive correlation because the more bread you bake, you have to use flour to bake bread. So the more bread you bake, the more flour you have to use. Okay? And it also has a causal relationship because as the number of loaves of baked bread increase, the amount of flour used increases. Okay? However, for B, the number of mailboxes and the number of firefighters in the city. Well, this is probably also this is probably also going to have positive correlation because as the city gets bigger and needs more mailboxes, they're gonna also need more firefighters, right? So, smaller cities, not as many mailboxes, not as many firefighters. However, installing more mailboxes does not mean that you automatically get more firefighters. So there is not causation, right? There one increasing this one does not increase this. However, increasing the amount of bread you bake does increase the amount of flour used. Okay, so that's kind of the difference here, is that these two are, one affects the other, and these two, even though they're positively correlated, they do not. Okay, let's look at that again in the got it problem. In the following situations, is there likely to be correlation? If so, does it represent a causal relationship? A causal relationship, sorry. The cost of the family's vacation and the size of their house. Okay. Well, they are probably they probably have a positive correlation, right? Because usually the cost of a family's vacation and uh, this goes up the bigger the size of the house that you rent. However, just because you spend, it's not there is no causation, right? Just because you spend more money on a vacation does not cause a family to have a bigger house. Okay? Right? So usually, right, you spend more money if you have a bigger house, you spend more money when you go on vacation. But having a more expensive vacation does not mean your house is going to be bigger. Time spent exercising and calories burned. This has a positive correlation, and it is a causal relationship, right? You spend more time exercising, you will burn more calories. Okay, so for our lesson check, um, right, here's some data. Make a scatter plot, draw a trend line, write its equation, predict the minimum daily temperature there. So I'm not going to draw a scatter plot, but we will get the equation real quick. So again, to get my equation, we go that the slope, let's pick 2 points. Let's pick oh, I can't see that one now. Let's pick the first one and the last one. So that's 39 minus 35 over temperature. Ooh, those are bad points to pick. Okay, does everybody see that I picked 2 points that really don't have a big difference here? Okay, so the latitude was 35, this one was 39. Okay, let's pick some that differ a little bit more. Let's pick these two right there. Okay, so the slope is going to be 43 minus 25 over 32 minus 76. So 43 minus 25 gives me 18. 32 minus 76 gives me negative 44. So 18 divided by negative 44 gives me a negative 0.4. Okay. So y minus, let's use the 25. Y minus y1 is equal to negative 0.4 times x minus 25. Okay, so y minus 76 gives me negative 0.4x plus 10. Add 76 to both sides, and I get y is equal to negative 0.4x plus 86. So there's my equation. If I wanted to predict the maximum daily temperature in January at a latitude of 50 degrees, I would just plug 50 in for x to get an approximation. Number 4, Given a set of data points, how would you decide whether to use interpolation or extrapolation? Depends on how far how far forward you're looking, right? So uh, if you have data over the sets of values, right? If the range of your data, if the domain of your data is in between what you're trying to look for, then you can use interpolation. If you're going past the data that you need, you can use extrapolation. How are a trend line and the line of best fit for sets of data pairs similar? How are they different? Both the trend line and the line of best fit show a correlation between two sets of data. And then the line of best fit is the most accurate trend line. Okay, so they're pretty much almost the same thing, except the line of best fit is the best one. Refer to the data table below. A student says that data has a negative correlation because as x decreases, y also decreases. Well, if x is decreasing and y is decreasing, right? If you think about your graph, if x is going this way, y is going this way, your data is going to look like that, which means it's going to have a positive slope, so a positive correlation. All right, and that was 5-7, scatter points and trend lines.